the whole time. But it bends. It's not just a straight uphill, it's not a straight line, it's got curve to it. This part of the curve right here, we say is concave down. It's like it's frowning. It's sad. Probably just came out of Spanish. This part, concave up. Because it's smiling. It just came out of world history. Now, the question is, how could we tell when a graph is going to be... We're trying to be able to graph these equations by hand without a calculator. So we need to know, is the graph smiling? Is it frowning? What's it doing on that interval? And it's not easy to tell. But let me go ahead and give you this one other piece of information, and then we'll talk about it. This point right here, where the graph changes from frowning to smiling, concave down to concave up, that's called an inflection point. An inflection point is simply a place where the graph changes concavity. And the interesting thing about an inflection point is that it occurs when the second derivative equals 0. Now, to understand why is a little bit difficult. The good news is you don't have to understand why. You just have to know. Inflection points occur when the second derivative equals 0. But I'm going to try to explain why real quick. And that's what these little tangent lines that they have drawn are about. Let me clear this off. There you go. I want you to think about the slope. Just the slope. Do you agree that the slope is pretty steep right here? But as we go, it's getting less and less steep? Would you agree with the idea that the slope is decreasing for this part of the graph? Now slope, another way of saying slope is f prime, right? Slope is decreasing means that, well, let me think about how I want to say this. If f prime is decreasing, would you agree that the slope of f prime is negative? If slope is decreasing, if f prime is decreasing, isn't f prime going downhill? And if f prime is going downhill, isn't the slope of f prime negative? The slope of f prime is the same thing as f double prime. That's hard. I understand, and I may have said that too quickly. But let me say the same thing over here and try to connect them together and then tell you, now you don't have to understand that explanation to do what we're about to do. But we will be using that explanation all throughout this unit. So as we go through the next few days, next few weeks, that explanation is going to make a lot more sense. Over here, as we go, is the slope increasing or decreasing? Increasing. Okay, slope is increasing. Another word for slope is f prime. If f prime is increasing, the slope of f prime is positive. But what's another way of saying slope of f prime? F prime prime. Okay, now I want you to think about this one last thing. Over here, f double prime is negative. Over here, f double prime is positive. What's the only way to go from negative to positive? What number do you have to cross? 0. So right here, wouldn't f prime prime be 0? The inflection point. That's hard to think through. That's very conceptual. But our job today is simply to find those points and tell where a graph is concave up and concave down. And that is actually fairly easy. So let's go through an entire example using what's called the second derivative test. Last week we learned the first derivative test. The first derivative test was for telling whether we have critical points and whether those are maximums, minimums, or neither. Well, now we're going to learn the second derivative test. and try to tell if those points are real inflection points, and if it's where we've changed concavity or not. And we're just going to do one example with an entire function. F of x equals x to the fourth minus 4x cubed plus 10. The directions say use the first derivative test to determine maximums and minimums of the given function, and when the function is increasing and decreasing. That's what we did last week. And then use the second derivative test to determine the inflection points and when the function is concave up or down. So this one problem is going to take the entire page, because we've got to do all that stuff. Jansen just shot me this nasty look.
I was just agreeing. Yeah. Killing some trees.
A nasty look, Jansen.
It was. It was not a happy look. It was not a sad look. It was a, I don't know.
I'm tired. I'm like capable.
Oh, okay. That's just a tired one.
It's like I am showing myself right now to make my hand move across this paper.
And to talk.
And to talk.
Okay, let's do this very quickly. F prime. First derivative test, just like last week, we find the derivative. The derivative would be 4x cubed minus 12x squared. If I do anything up here that doesn't make sense, just stop me. If I make a mistake, politely correct me. Set it equal to 0 and solve it. Now to solve it, you'll factor out what they have in common, which is 4x squared. You'll have x minus 3. If factoring is an issue, let me know. Once you've factored, you set each part equal to 0. And here we'll divide and do the square root and get x equals 0. Here we'll move the 3 over and get x equals 3. So we have two critical points. Critical point at 0 and a critical point at 3. How do I get y value?
You plug it in to the original equation.
Oh, Jansen.
Thanks, Jansen. I forgot you were missing a tooth. Your name was not picked by the board. You couldn't remember.
It's okay, I got the same answer now.
Okay, so you plug a 0 back in the original equation and you will get 10. That's easy. You plug a 3 back in the original equation, you got to do a little bit of stuff. 3 to the fourth is 81, right?
Yes.
3 cubed is 27 times 4 is 108.
Correct.
You're just saying correct.
Plus 10.
So we end up with 81 plus 10 is 91. Minus 17. Looks good to me.
So, did we get a calculator for that part?
I didn't need one.
You didn't.
That's how we like it, Matt. Like no calculator work.
F prime. You know, the answer is no, you don't get a calculator, because if you got a calculator, wouldn't all of this become trivial?
Yeah, true.
So 0, 3. Okay, now I've got to do my tests, so I've got to pick numbers, and Michelle, where am I going to plug those in? Into your derivative. And I would plug them into the factored form. So I plug a -1 in here for x, and I'll get 4 times -1 squared is positive, 1 minus 2 is negative, so that's going to be negative. Plug in a 1. 1 squared positive, 1 minus 3 negative. That's weird. Negative, negative. Plug in a 5, you get positive. And so you're right, 0, 10 is a fake. What is 3 negative 17?
It's a minimum.
Minimum. And it's a minimum because we go from negative slope to positive slope. And if we go from negative to positive, then it's minimum. So here's what we know so far. Oh, and it also asks us to list where we're increasing and decreasing. So let me do that. Increasing. We're increasing wherever the slope is positive, so from 3 to infinity. We're decreasing whenever the slope is negative. So from negative infinity to 0, and from 0 to 3. Bethany, you look terribly bored over there.
Oh no, I'm
Laura
very
better
interested.
Appreciate this.
Yeah, it's too close.